Good morning, dear students. I am Dr. Batani Srinivas, Professor of Chemistry in St. Peter Engineering College. Okay. Today I am going to discuss disinfection or sterilization. What is that? Disinfection and sterilization. Or sterilization. So this is the topic we want to complete today. Okay, yesterday, so what we have discussed in the last class, what we have discussed. We have discussed the specification of potable water and steps involved in the purification of potable water. So please tell anybody, what are the steps? There are sources of water, screening, aeration and sedimentation, coagulation, filtration. The last step is sterilization. What is that? Last one is the sterilization or disinfection. So what is it means? Sterilization, we know, everybody knows. Sterilization is nothing but a removal of microorganisms. Removal of microorganisms. When water is passing through sedimentation, coagulation and filtration, yesterday all these we have discussed. The water is passing aeration, sources of water from lakes to aeration, then sedimentation, coagulation and filtration. Still contains small percentage of pathogenic bacteria. So its removal can be achieved by sterilization or disinfection. So we can remove by using the amount, the microorganisms can be removed by the sterilization. So what are that sterilization? So general method in our home we are using simply what? Our mother says what? Simply boil the water. Then municipality doing some chlorination, mean additional bleaching powder, adding of chlorine gas and chloramines, and some companies costly methods ozonization are also there. So what are the topics we have to use? So in this, what we have to use? First one is the boiling water. And second one is chlorination. What is that? Chlorination. And third one is the ozonization. These three are very important. Boiling water, chlorination and ozonization. If you are doing before drinking the water, the bacteria will kill. Okay. So one by one we have to discuss. Okay. Boiling water. The water is boiled for 10 to 15 minutes. 10 to 15 minutes. So most of the bacteria killed. So take the water and boil 10 to 15 minutes. So total water will be removed. That is about the simple boiling method. Okay. So next one is the chlorination. So chlorination. So chlorination means, so in that chlorination, actually, the process, what is meant by chlorination? The process of adding chlorine, to water is called chlorine. Simple. What is that? The process of adding chlorine to water is called chlorination. The chlorination can be done by the adding of chlorine gas. And adding of chloramine. And also adding a bleaching powder. So as to what? Why we are adding this? Adding a bleach powder? So it is to fit for human consumption as drinking water. So what is that? What is meant by chlorination? The process of adding chlorine to water is called chlorination. So chlorination can be done by addition of chlorine gas, addition of chloramines, addition of bleaching powder, so as to fit for human consumption as drinking water. So that is the chlorination. So now we will see that first of all, if we add the bleaching powder, so what happens? So bleaching powder in calculated amount is added to water. Bleaching powder in calculated amount. Calculated means, so how much of water is there, how much we want to add to the water. So what is the formula of bleaching powder? We know the bleaching powder formula. What is the formula? So calcium oxychloride is the chemical name. What is the formula? CaOCl2, bleaching powder. We have to see the bleaching powder. So CaOCl2, bleaching powder. What is the chemical name? Calcium oxychloride, bleaching. So addition of bleaching powder to water. So what happens? Calcium hydroxide formation takes place. Calcium hydroxide and release of chlorine gas. So what is the purpose of adding of this one? To release the chlorine gas into the water. That chlorine gas again react with the water to form the what? HOCl. What is the HOCl? What is the name of HOCl? Hypochlorous acid. What is that? Hypochlorous acid plus HCl. Hypochlorous acid. So hypochlorous acid is responsible for killing the bacteria. Hypochlorous acid is the responsible for the killing bacteria. So this is most important. So why we are adding bleaching powder to the water mean simply bleaching powder when react with the water to release the chlorine gas and formation of calcium hydroxide. So then again the chlorine react with the water to form the hypochlorous acid. This hypochlorous acid is responsible for killing the bacteria. This is the just addition of bleaching powder. Now addition of chloramines. The second one is the addition of chloramines. So chloramines mean what? If chlorine gases react with water, how much percentage? When chlorine and ammonia are mixed in the ratio of 2:1, a compound chloramine is formed. What is that? Chlorine plus ammonia. Chlorine gas, how much percentage? 2:1. So 2 moles of chlorine and 1 mole of ammonia react to form what? ClNH2. This is the chloramine. ClNH2 plus HCl. So this chloramine, this is the chloramine. This is the chloramine. So chloramine So mean 2:1 ratio, mean chlorine and ammonia combined together to form the chloramine. That is the formula is the ClNH2. ClNH2. That is the called chloramine along with the acid chloride. So chloramine compound actually decomposes slowly to give chlorine. So chloramine, finally hypochlorous acid is must. So the chloramine again react to water and it decomposes to form the hypochlorous acid. So we know that hypochlorous acid is the responsible for killing the bacteria. So how the chloramine, this chloramine ClNH2 react with the water to form the HOCl plus ammonia. NH3 ammonia. So hypochlorous again. So this is, we know, hypochlorous acid. This is responsible for killing the bacteria. Okay. So what we have completed? Addition of bleaching powder, addition of chloramine to the water. So what compound is formed? HOCl. The chemical name is of HOCl is hypochlorous acid. So it is the responsible for killing the bacteria. Okay. So these are. And one more that is most important is the chlorine gas. Chlorine gas. So please note down. Chlorine gas, addition of chlorine gas. Chlorine gas can be bubbled in the water as a very good disinfectant. So chlorine gas, what we have to see? The chlorine gas, I will draw the diagram also. So when we have to add the or bubble the chlorine gas, so among all the halogens, chlorine is a gas at atmospheric. Chlorine is a gas at atmospheric, but at high pressure, under high pressure, chlorine can be liquefied. So simply, so chlorine gas can be bubbled in the water because the reason is a very good disinfectant. Among all halogens, halogens mean chlorine, bromine, iodine. So these are the halogens. Among all the halogens, chlorine is the most efficient disinfectant, most efficient. So chlorine gas at atmospheric pressure, so is a gas at atmospheric pressure, but liquefies under controlled pressure, under controlled pressure. So the liquefied gas mean, so we can transport to anywhere. So we have to store in cylinders. Okay, the liquid gas is transported used as such direct as a strong oxidizing agent. It is it kills the pathogens via the oxidation of organic molecules. So how? I will tell you. First, so we have to know that how it is happened. So just draw the diagram. So chlorine gas we can, so under liquefied it is a chlorine gas is there. So this is the gas cylinder, okay, one pipe. So this is the regulator. This is the gas, Cl2 gas. So from here, so tank, what tank? Water tank. So gas is coming like this. Now this is the water. We know that the chlorine gas slowly, so the regulator we can control by using this regulator. So regulator for the purpose of the speed of chlorine gas. Okay, so now here what happened? Chlorine react with the water to form H2O, hypochlorous acid. So we know that hypochlorous acid is the responsible for that killing of the bacteria. So this is called the what? So you know the how much of pH is there? H plus. So actually HO plus pH is the 6.5. So here the 6.5. 6.5. So in here actually HO plus H plus OCl minus. So how much pH is? So greater than 6.5. 6.5. So we know that hypochlorous acid is formed, that is the responsible for the killing of the bacteria. So finally, sterilized water. This is called the sterilized water. Sterilized water. Okay, sterilized. So in this, one breakpoint of chlorination, that is most important for examination point of view. This is the chlorination, sterilized water will come and we will drink. This is for the human consumption. So breakpoint of chlorination. So what is meant by the breakpoint of chlorination? That is important. Please draw this diagram. Breakpoint of chlorination. Breakpoint chlorination. Simply breakpoint of chlorination. We can write breakpoint of chlorination. Okay, breakpoint of chlorination. So what is meant by breakpoint of chlorination? What is meant by breakpoint of chlorination? So it is a process which involves the addition of excess of chlorine. It is the process of involves the excess of chlorine so as to oxidize organic matter, reducing substances and free ammonia. In the water, what are there? Organic matter is there, reducing substance is there, or free ammonia there. In raw water, when the chlorine is, excess amount of chlorine is added to the water. So the excess of chlorine oxidizes to organic matter, reducing substances and free ammonia in raw water, and leaving behind free chlorine. That imparts disinfecting action against disease causing bacteria. The results of increasing doses of chlorine can be depicted in the form of one plot, one graph. Okay. So what is the chlorine residual versus chlorine doses? So what happened when the once again listen, what is meant by breakpointing? Remember, it is a very important. It is a process which involves addition of excess chlorine so as to oxidize organic matter, reducing substances and free ammonia in raw water, and leaving behind free chlorine that imparts disinfecting against disease causing bacteria. The result of increasing doses of chlorine can be depicted in the form of one graph. So the graph is actually what? Residual chlorine versus excess of chlorine doses. So what is that graph? We will see that. What is the graph? Actually, the graph is how it is open. The graph is how we can see that graph. So what is the graph? So in the graph, so what is the graph is like this. In this 1, 2, 3, 4. So the versus graph what? Chlorine doses added, mean chlorine doses. Chlorine doses versus chlorine residue. Chlorine residue. So in first of all, what reducing substances here 1, 2, 3, 4, 5. First is what? Chlorine is oxidized. What? Reducing substances. Reducing substances. Then formation of chloramines. Here formation of chloramines and destruction of chloramines. Destruction of chloramines. And finally sterilized water will come. Sterilized water. This way. So one by one, so we will discuss. So in the group. In the first phase is what? First phase. In phase 1, what is that? In phase, this is the phase 1. 1, 2, 3, and 4. Good. In phase 1, the chlorine is reduced. Chlorine is reduced by easily oxidizable stuffs like H2S, manganese, and iron. These are the reducing substances by easily oxidizable stuffs in this first phase. In the second phase, chlorine is consumed by reaction with the organic water. And if ammonia is present, what will form? Chloramine formation begins here. Chloramines. Already I told you, formation of chloramines. If ammonia is formed, formation of the chloramines will start in the second phase. In the phase 3rd, what happened in the phase 3rd? Chloramines are broken down, mean destruction takes place. Chloramines will broken down and converted into nitrogen gas. So destroyed and converted into nitrogen gas. Nitrogen gas is evaporated from the system, which leaves from the system. So that is called the break point. You can say here the break point will start. Break point takes place. After this point, oxidant demands has been destroyed and disinfection can be proceeded. Here so in this stage, after this point, after the destruction of chloramines, here this is called the break point. Break point. So here that kills the bacteria. So all the bacteria. The addition of chlorine at the tip or break is called breakpoint chlorination. What is that? The addition of chlorine at the tip. So after the destruction of chloramines, again chlorine is there excessive at a point, at a break is called breakpoint chlorination. What is that? Once again, the addition of chlorine at the tip or break is called breakpoint chlorination. At this point, free residual chlorine begins to appear. Here, free residual chlorine. So here, so free residual chlorine begins to appear. So it is also called as what? Available chlorine. You can say available. So we can say free chlorine. What is meant by free chlorine? available chlorine, free chlorine, residual chlorine. So three points are there. So this is called the break point of chlorination. So in the break point of, once again listen, simply how many? 1, 2, 3, 4. So in the break point of chlorine, excess of chlorine. So first react the residual substance like hydrogen sulfide, H2SO, manganese, iron. Then again react with in water. If ammonia is present, formation of chloramines. Then in the third phase, chloramines will be destroyed and nitrogen gas is released from the system. And here leaving behind here one point dip is there. The addition of chlorine at this dip or break is called the break point of chlorination. So this is also called a available chlorine or free chlorine or residual chlorine. So this graph is versus what? Residual chlorine and chlorine doses. Residual chlorine. So this is about the chlorination and break point of chlorination. So if we'll thus, what is meant by chlorination? Means just you write the addition of chlorine and break. If they will ask the break point of chlorination, you have to write these things. Okay? So this is very important. And finally, ozonization. One more topic is there, ozonization. So please note down this graph and everything. So it's very easy. We know this ozonization. So what is the formula of ozone? Ozone formula, anybody? O3. O3 is the ozone. Ozone, you have to remember. So ozone is an unstable molecule which readily breaks down. Ozone is an unstable molecule which readily breaks down, liberating what? It breaks down in how many oxygens are there? 3 O's are there, 3 oxygens. If it breaks down, unstable mean, if it decomposes mean, what will release? Liberating of one oxygen mean O2 less oxygen. Mean when O3 unstable gas, unstable, and release of nascent oxygen. Oxygen and nascent oxygen. This is oxygen plus nascent oxygen. So ozone is an unstable molecule which readily breaks down, liberating one nascent oxygen, one atom of oxygen. The nascent oxygen is very powerful. It is very powerful and oxidizing agent and is capable of destroying the harmful bacteria in addition to oxidation of organic matter. Not only oxidation of organic matter and destruction of complete bacteria, pathogenic bacteria. So this is most important one. So how can we know this? So one diagram, I will draw this diagram here. So first we have to so see. First, how to form the ozone? We have to know how to form the ozone. Formation of ozone, we have to know. One reaction I will tell you, then draw the diagram. So first oxygen is there, available. Oxygen is available. If 3 moles of oxygen passing through UV light, if 3 moles of oxygen passing through to form the O3, to form the ozone. How many moles will form? 2 moles of oxygen, because 6, 3 moles. So 3 moles of 3 moles of oxygen under passing UV light to form the ozone, 2 moles of ozone. So it is unstable. So it is an unstable one. Unstable one. So it will again form release of one atom, that is nascent oxygen. So here, so this is the formation: UV light, oxygen, UV chamber, then pass to the one. So this is the water tank. So readily prepared, here oxygen, then O3. So oxygen slowly passing through the water content tanker. Then here what happened? Not only oxidizing the organic matter, it destruction of bacteria, and sterilized water will come. Sterilized. So this is called this process is also called as what? Ozonization. To use ozone as a disinfectant, it must be created on site, because immediately on site, and added to the water by bubbled to contact. Bubbling will take place, the bubbles. The ozone is passing to the water. So this is what? This is a simple ozonization. Ozone is made by passing oxygen through UV or cold electrical discharge. UV chamber, or we can say cold electrical discharge. Cold electrical discharge. Immediately on site we have to prepare the ozone. Just oxygen passing to the UV chamber or cold electrical discharge, and ozone formation takes place. The ozone is bubbled into the water. Immediately destruction of all the bacteria. Then the pure sterilized water will come. So this is the ozonization. So what we are discussing today: disinfection or sterilization. Chlorination. In chlorination, what are they? So by boiling water 10 to 15 minutes, or addition of chloramines, addition of bleaching powder, and addition of chlorine gas, that is a chlorination, and breakpoint of chlorination, and ozonization. So these are the topics we have discussed today. Okay, thank you very much. Tomorrow we will discuss the internal treatment of water. Okay, thank you.